Hey guys, welcome back to the Python networking course, or I don't, is it a course? Maybe. But today we're going to be inserting the code into the TCP client class. The first thing we got to do is look at the constructor. We're just going to set some variables. Once again, this is going to be pretty similar to the server class. So the first thing we're going to do is self.ip_address is equal to IP address, self.port is equal to port, self.sock is equal to socket.socket. We're going to go family equals socket I cannot type .af inet, and then type is equal to socket.sockstream, and let's make this a private variable. And just to follow the naming convention, we're just going to make this client, since the socket for the server was called server. So we're going to go self.packetSize is equal to packet size, and then the Boolean variable, so self.connected equals false, and then self.hasInput. Alright, next we're going to do the run method. So this is going to look pretty similar. We are initializing some threads. So we first want to connect to the server. Initialize message thread. And then initialize input thread. So to connect to the server, we just go self.sock.connect a tuple with self.ip address and self.port, and then we're going to go self.connected is equal to true, and then we're going to go to the callback, which is self.client connected, and that is this method right here. That should be overridden. And speaking of overriding, say do not override. Alright, for the message thread, we're going to go server thread equals threading.thread. You guys get the gist now. And then target is equal to self.serverThread. Once again, this just says that the target of the thread, what the thread will be running on, is the server thread, this one right here. We're going to set this one to daemon because we want this to automatically end when the program ends. Set daemon true, and then we want to start it. Thread.start. Did I make oh, you know what I did? Let's just make this a self dot, because I did that in the server class as well, and we'll make it private too. Just because. Alright, and then we want to initialize the input thread. So if self.hasInput, self.input thread equals threading.thread, and the target is self.input thread, and then self.input thread.start. So one thing that I was thinking about when I was writing this code is if input thread is equal to false, then we're not going to have a non-daemon thread. So all our threads are going to be daemon, and the program is just going to end immediately. So the way it's going to be, we're going to write the program is if we set hasInput equal to false, that's going to be a deliberate thing, because we're going to have another thread that may be connected to a GUI that will keep the program alive. So if, for example, in the TCP listener, if we set if this thread never runs and we don't have another thread running that is non-daemon, that the program will end immediately. But because it's going to be encouraged or recommended that you do have another thread, this will not be an issue. So that clears that up. I was just thinking about that in between videos. So next we're going to want to do the server thread, and we do not want people to override this one here. And then in the server thread, it's pretty much going to be the same thing as the client thread on the server. So we're going to have a placeholder message equals nothing. We're going to have a infinite while loop. We're going to have try and accept. And if you guys want to print out errors, you just go exception as E, and then you just go print E. But I'm not going to do that for now because unless we run into an error, I really don't care what was thrown. Because the program, this exception, is just trained to deal with if there's an error in communication. So communication must disconnect. We're just going to self.server disconnected and return. We also want to just close the sock. Self.sock.close, just that, and then self.sock.close. Once again, if we break out of the while loop, and self.server disconnected, just like that. Or actually, let's put the server disconnected in front just in case you want to send like a goodbye message before you close the socket. You know, if you want to be all courteous and nice to the server. But once again, this is the same gist. While true, get the message. So we're going to go data equals self.sock.receive, self.packet size, and we're going to go decode in Latin 1. So this is going to return bytes, and we want to decode it using Latin 1. Packet size we initialized up here in the constructor. And then we want to find that end tag. It's -8 to the end equals finish. We're going to want to just add, this marks the end of the message, so we just want to, just go back to the image, we just want to go from this over to where the finish starts, so this area right here. So that marks the end of the message. And we're just going to add plus equals data, the beginning of the packet to -8, or to 8 from the end, and then we want to break out of the while loop, and then if, wait, no, I forgot to add something here. Otherwise, we're just going to add the whole packet, so message plus equals data, and then if not message, break means the client disconnected, else if message that is space. Once again, this is just something from experience. It's going to continue so that it's not sent into the message processing and create errors. So self.message received, message, and that is a callback. And then we want to reset the message. Just like that. So that is our server thread. The input thread is going to be override that we want people to override this. Send, this is going to be the same as the server one. So we're first going to convert into bytes. So we want to modify the message. So we're going to make a new variable send byte, send b, signifying the bytes, equals message.encode to UTF-8 if do encode, else message. So once again, I'm just going to explain this again. So that statement there is equal to if do encode, send b equals message.encode UTF-8, else send b equals message. You see it converts 4 lines of code into a single one. So I can just get rid of that. So next we just want to add the end tag, so send b plus equals finished a string, and we're going to encode this into UTF-8. And next we're going to want to break up message and send individual packets. So size equals length of message, send b, got that. we're going to have a placeholder index starting at 0, while IDX is less than size minus self.packet, no, not equals, minus self.packet size, self.sock.send, send b IDX, IDX plus self.packet size, IDX plus equals self.packet size. So this is just incrementing the index, so we'll go back here. Index starts at 0. If there is a whole packet worth of content, you send that whole packet, this whole thing, and then you increment by a singular packet size to get to the next one. And because there's not a whole packet left, you only send to the end, which we're going to put right here at the out of the while loop, because there's some leftover content. So self.sock.send, send b IDX, and yeah. This stuff is going to sound confusing because I'm saying send a lot. Just know that this is how I like to name my variables, by what they do. It's good coding convention to do that, just so it's easier to read the code. It's harder to read, like, say the code aloud because it gets all confusing. But yeah, if you want to mute me, then go ahead and do that. I don't care. It doesn't make a difference to me. And just watch the code. That works too. So the next, that is it actually for the code. We just want to put the override guides. So don't override client connected, override server disconnected. We want somebody to override this, and then message received, same thing. So yeah, that wraps it up for the TCP client class. In the next video, we're going to be putting this all together in a test, and yeah, that's going to be exciting. We'll probably be creating like a mock chat server. And the beauty of this is the way we created it is it can take multiple clients. That's why we created the list of clients right here in the TCP listener class. So yeah, that's something to look forward to, and I'll see you guys in that video. Bye.